The Materials Science and Engineering Department has a long history of academic excellence. We started off in 1940 as the Department of Metallurgy in what was then known as the College of Mines and Engineering. In 1985, we became the Department of Materials Science and Engineering and expanded our expertise and capabilities to encompass a wide variety of advanced materials systems that enable technological innovation.
The Department of Material Science and Engineering at the University of Arizona is teaching and doing research ranging from space materials to quantum materials to biomaterials.
We have very strong growth in research in the areas of additive manufacturing, topological and quantum materials, semiconductor manufacturing, and materials informatics.
The state of Arizona has now become the hub for semiconductor manufacturing here in the United States. In the past few years, over $70 billion has been invested in Arizona to establish 4 new semiconductor manufacturing facilities that will create over 100,000 new jobs.
We have very significant workforce training needs here in Arizona as we seek to expand manufacturing here in America. We're expanding here in Arizona, we're expanding across the nation, and the University of Arizona is working to support both workforce needs and research and development needs for the semiconductor sector.
This Center for Semiconductor Manufacturing ensures that we are forward-looking. It supports research in developing new emergent materials for semiconductors, heterogeneous integration and 3D packaging, and in addition works a lot on code design development.
The research that's done within the Center for Semiconductor Manufacturing spans an enormous number of disciplines, from purely computational simulation work to very experimental work. Embedded in that portfolio is a lot of work on materials. For example, we're working on 2-dimensional materials which will allow us to manufacture semiconductor devices that are smaller and faster and lighter and more efficient.
Our research focuses on pioneering the use of low-dimensional materials such as graphene, carbon nanotubes, molybdenum disulfide, and black phosphorus for making the next generation technologies for neuromorphic computing and AI. So our goal is to leverage all these advanced materials to overcome the limitations of size and energy efficiency in the current digital computings.
The NSF has awarded $30 million to fund the establishment of the New Frontiers of Sound, NUFOS, Science and Technology Center within the Department of Materials Science and Engineering.
And in this center, we exploit these extraordinary properties of acoustic metamaterials and phononic crystals to address grand challenges in information science, telecommunication, and sensing. So my research focuses on topological acoustics, which is an emerging field that is spanning the use of acoustic metamaterials and phononic crystals to achieve extraordinary properties for acoustic waves.
Our faculty are great and they come up with tremendously innovative ideas, but our amazing students are the ones who really do the heavy lifting and get the research done. The University of Arizona is a designated Hispanic and Native American serving institution. As a result, we have many first-generation college students who go through our program, get great engineering jobs, and are able to be elevated up on the socioeconomic ladder. This is part of the mission of the University of Arizona, and is truly a rewarding part of being a faculty member here.
The students at the Department of Materials Science and Engineering are truly the heartbeat of our department. Both undergrad and graduate students are intimately involved in many research activities within the department. The graduate students not only gets to work in a highly interdisciplinary environment, they get serious mentorship experience by working with undergrads as well as postdoctoral associates in the department.
The Department of Materials Science and Engineering has effectively an undergraduate curriculum which we call workforce ready, which means we're training the students to become the future workforce for semiconductor applications or industry, but for other applications in aerospace, for instance, or automotive industry.
Here in the MSc department, as we motivated to inspire students, developing them into the next generation of innovators and be prepared to address global challenges.
The state of Arizona is quickly becoming a manufacturing powerhouse and home to many technologically advanced companies. I'm super excited about the MSc department here at the University of Arizona, as our faculty, staff, and students are working on design-enabling materials that will really help us transform the future.